Hello everyone and welcome back to our lecture series on the blockchain course, Architecture, Design and Use Cases. We are now going to dive into the financial services industry and why people think blockchain is going to completely transform the face of how financial services work today. So we're going to look at 3 lectures looking at different use cases. So this lecture is going to be focusing on just payments and securities trading. So there's one aspect of financial services we're going to look into today and how blockchain can completely transform this landscape and what are the existing pieces of work, who's working on this, what are they doing, and gives you a sense of where we are and how some of the first production networks are coming out in this area. Cross-border payments. So this is the classic use case for which Bitcoin itself was created, and you could call it the holy grail of cryptocurrencies, right? So today we have over 1,500 cryptocurrencies, a huge number of them, providing various different kinds of concepts. There are a lot of ICOs coming up. This is the initial coin offerings. There's a whole lot of activity here, and a lot of startups, a lot of venture capital funding in the space. I would really call this completely, there's too much action going on for any person to even follow. But what is really a currency, right? I think we should step back and take a technical look at whether these cryptocurrencies are really currencies in some way. In economics, a currency has to follow the following criteria, and only then it is actually accepted as a currency. Today, for regular laymen, a currency is something like the Indian rupee or the US dollar or the euro. They're all currencies. But why do we call them currency? What are some of the properties that all of these satisfy for them to be accepted as a currency? So first is, it has to be a medium of exchange. So in some sense, what this means is, are there merchants today who are willing to accept the currency in exchange for goods and services? Can I go to a shop or can I go to an online place where I pay in INR? Today that's true for Indian rupee, it's true for USD. I can go to a shop, I can buy a TV in exchange for Indian rupees. Now that is a medium of exchange where there is an exchange of goods. So a seller is selling a set of goods or services to a buyer, and the buyer pays in terms of this currency, right? So that's a medium of exchange, and that is important. So merchants should be willing to accept this currency. In the Bitcoin world, yes, there are a few very limited set of merchants who are accepting Bitcoin today as a medium of exchange. But in many countries, the government has actually banned the use of Bitcoin or any other currency as a medium of exchange. There are many reasons for this. Maybe we've already covered that, some of the operational issues, some of the technology issues with Bitcoin and other cryptocurrencies, why people are not recognizing this as a medium of exchange. So my vote on this would be Bitcoin satisfies this criteria only partially. There are very few merchants today in the world who would accept Bitcoin in exchange for goods and services. So that's the first criteria. The second criteria, again an important criteria, is that it has to be a unit of account. So what does that mean? What it means is that, is it a measure of real value of goods and services? So today, if I go to, let's say, a store, I want to buy a television. The price would say, okay, maybe it says 10,000 rupees. I'm just going to take it as an example. The television is tagged as 10,000 rupees. And the value of that 10,000 rupees is typically independent of the value of the Indian rupee itself. So you know that Indian rupee, there are exchange markets that would price the Indian rupee with various other currencies. For instance, conversion with the US dollar or the euro. So that rate changes on a daily basis, actually even intraday. Right? The value of the rupee keeps fluctuating. But just because of the value of the rupee fluctuating, the value of the good that you pay for is not fluctuating. You're always, whether it's you go today or tomorrow, it's going to be 10,000 rupees. There might be other reasons why the price changes. There might be inflation over 3 months, that 10,000 may become 11,000. But that is not what we are talking about here. Regardless of the fluctuation in currency, is what I pay for a good or service, is that the same, right? So that is the real value of goods and services. That is what we call as a unit of account. And for almost every cryptocurrency today, I would say that it actually fails this criteria. Today, people, even merchants, are willing to accept cryptocurrencies in exchange for goods and services, but the amount of cryptocurrency they accept, they would actually do a conversion factor with how it's trading with, let's say, the USD. Say today, let's say Bitcoin is trading at $8,000. You might say, I will accept so many Bitcoins in exchange for this service. But let's say the Bitcoin price goes to 9,000 or 7,000. They will adjust it to match the USD price. So they actually have a USD price, and that's the real value. And Bitcoin is just a medium of exchange in that case. It's not a unit of account. So it has to be independent of fluctuation in currency, and that's when it will be accepted as a unit of account. So merchants should be willing to accept, let's say I put a price as 2 Bitcoins. It has to be 2 Bitcoins regardless of what the price of Bitcoin is relative to other currencies. That's when it's a unit of account. And the third criteria is it a store of value? Today, if you take, for instance, gold, I would say gold is a store of value. People are willing to invest in gold as a trading instrument. So I could park some amount of the currency that I have, I can exchange it for gold. Right? So gold is a store of value, is almost never a medium of exchange. Today, if I take some gold coins and try to buy a television, it's not possible. A merchant is not going to accept that. Right? But it is a store of value. Right? So that way gold is a mode of investment. And today's world actually is treating cryptocurrencies more a store of value than of anything else. Right? It is a mode of investment, maybe speculative investment. They speculate that the value of these cryptocurrencies will rise over time, and so they are investing in it, in buying those cryptocurrencies. So this, I would say, the cryptocurrency world today is actually satisfying the store of value criteria for a currency. It almost never satisfies the unit of account criteria, and maybe in some cases satisfies the medium of exchange criteria. So I would say until it satisfies all of these criteria, it is not going to be called a currency in the true sense, at least in the sense that economists think about it. And that also may be a way to explain a lot of the hesitation to get into cryptocurrencies that a lot of people have shown. Right? I hope this gives you a perspective of what we mean by currency and what it means to exchange currency for goods and services. And that is the core of payments. Right? You need this kind of a currency that satisfies these properties to be able to do payments. So we look at a few networks, blockchain networks or distributed ledger networks that are all payment networks in some sense, or primarily for the purposes of payment. So the first one we'll look at is called the Stellar protocol, and they have a network running. It's a global network. It's actually a decentralized hybrid blockchain platform with open membership. So what this means is anyone can join this network, run a Stellar node, and they can be a participant in this network, execute transactions and store the state of payments or accounts in this network. And they have a cryptocurrency called Lumens. Right? And that is the native asset on which trading happens on the Stellar network. But what I like about Stellar really is the protocol that they have. They have a federated Byzantine agreement protocol. What is federate? What does this mean? And there was also a term hybrid here that I didn't explain properly. So although this is an open membership where anybody can join, what happens is the way consensus happens on the network is actually happening in 2 layers. The first layer is creating a set of quorums or a subset of these nodes in some way amongst this large set of nodes. So let's say there are 1,000 nodes in the network. I can break these up into smaller quorums based on current business agreements of the participants. And within each quorum, there is going to be a Byzantine agreement. There's going to be a Byzantine algorithm that happens. And that Byzantine agreement, if you think about it, is something that runs in a closed network. So within that small subset of nodes, they're going to execute a Byzantine fault-tolerant algorithm. But that happens several times over several of these quorums across the network. And many of these quorums can also intersect with each other. They will, in fact, intersect with each other. And the higher level protocol will ensure that everyone in the network sees a consistent state. So it's almost happening at 2 levels. One is breaking things down into quorums, agreement within each quorum, and then agreement at the overall network level. So it has good properties. It has 2 to 5 second transaction clearance. So when I submit a transaction for a payment on the Stellar network, it will pass through in 2 to 5 seconds. That's not too bad for a blockchain platform. It's still not at the level of, let's say, a Visa or a MasterCard network where I can swipe a card, it'll get It'll get through in a fraction of a second, but it's still reasonable, I would think. What the network itself is formed by a set of anchors, or they act as bridges that allow you to convert existing currencies. So you can convert US dollar to stellar lumens, right? And then the lumens pass across in the network. So that these actually act as the currency converters. And internally, it also has a distributed exchange. So let's say me sitting in India, I want to transfer money to somebody in the US in US dollars. So what the Stellar network will do is I ask Stellar to transfer, let's say, $50. The Stellar network will figure out what is the best way to convert Indian rupees to, in this case, let's say, euros, right? So what is the best way to convert from one currency to another? It might be, because based on how the network is created, there might be a direct conversion available, INR to euro, or it might be INR to USD, USD to euro, right? That is possible. But all that is happening automatically within the network. It will be converted for you at the lowest rate that's available. So I'd encourage you to look up Stellar. It's a very interesting project, and they have a good set of people on board using that network. So another interesting project is the Ripple protocol and the associated network. Actually, Stellar was a spin-off from Ripple. So Ripple was the first one that came out in terms of creating such a payment network, I would say, after Bitcoin. And Stellar is an offshoot of Ripple. So they broke away from Ripple. So it's a protocol that instead of end users, they actually look at banks. They target banks to help banks do clearing and settlement of payments. And it's done in a decentralized manner. They have their own consensus algorithm. Again, it allows exchanges and remittance to happen. And they also have a similar transaction clearance. They have about 5 seconds to run their transactions. But important thing is there is no mining in this case, unlike Bitcoin. Right? So Bitcoin has proof of work and it involves mining. But here they are only looking to create that network among a set of permissioned entities or banks. And they have a custom protocol, but that protocol, unfortunately, no one has validated it for correctness and fault tolerance. So it's still being debated whether it's a good protocol to use. They have, again, similar to Stellar, they have gateway nodes to convert currencies from fiat currencies, that's like the US dollar or euro, to Ripple. And for Ripple, it's the XRP. That's the cryptocurrency that they use. And they have market makers that help convert one currency to another. And unfortunately, Ripple has a centralized governance model. So Ripple controls who joins the network, how is this created, and so on. And they also hold a large fraction of the cryptocurrencies still. And the last I saw, they were holding about 60% of all XRP, which is a bit of a concern because people are worried that they can manipulate how the price of XRP using the large pool of currency that they hold with themselves. So that is Ripple. Again, an interesting protocol from at least a technical standpoint. It's an interesting one to look at. So I would encourage you to look up Ripple. So apart from these networks, people are looking to build permission networks for payments and settlements. So if you look at the current way in which the world operates today for payments, it actually happens through a very complex set of correspondent banking agreements. So today, if let's say I am to send money from India to the US, then I will ask my bank to send money to my friend's bank in the US. And the way it will work is there'll be a set of banking arrangements between my bank and the US bank, either directly or through intermediate banks. And all this happens through what is called nostro-vostro accounts. So what are these? Right? So nostro is a Latin word which actually means ours. So it's really, nostro account is, let's take a particular bank, right? Let's take Bank A. A nostro account for Bank A is Bank A's account in Bank B. So Bank A holds an account in Bank B, and likewise a vostro account is your account. So Bank A will hold an account for Bank B. So it's a correspondent agreement. A has an account with B, B has an account with A. From Bank A's terms, their account in B is called their nostro account. Bank B's account with them is called their vostro account. So this is used primarily because Bank A and Bank B might be trading in different currencies. So Bank A might be using INR, Bank B might be using USD. So Bank A's account with Bank B will actually have its balance in US dollars. So that allows it to perform transactions in the native currency of the other country. So those Nostro accounts are helpful for that. Now people are looking to put some of these kinds of accounts on blockchain, right? So with blockchain, again, we are only going to have the set of member entities, a set of permission set of banks participating in this network, and all transactions can be held private and confidential to the transacting entities. And what blockchain helps bring about is completely eliminate the need for reconciliation or errors that might crop up. So today, the way the Nostro banking accounts work is, let's say there are 100 such people from Bank A transacting with Bank B. Likewise, there may be 200 people from Bank B sending money to Bank A. All of these are netted together. So in some ways, they're all accumulated, and together they will determine what is the exchange between Bank A and Bank B at the end of the day. In some ways, it's like the RTGS. If you're familiar with real-time gross settlements, we have it in India as well. It's a popular way of exchanging money. In some ways, it's the same thing as that. But it can significantly help reduce the cost and delays involved in clearing and settlement of payments in these networks. And the other advantage is, let's say the treasury is part of this ecosystem, then they have an instantaneous view into the currency position across all the accounts. So I can immediately see how much INR is held in US banks in US dollars and vice versa. So it gives you an immediate, instantaneous, or almost a real-time view of currency positions in various banks across the world. And likewise, the Reserve Bank, if they are part of this network, they can use all of this information to do some of their policy management, right? So monetary policy is determined based on how much liquidity is there in the market, how much cash is flowing around. So all of these, the Reserve Bank can have a clear view into all of this if they are also on the blockchain as maybe an auditor. Right? They may not be transacting on the blockchain themselves, but the visibility helps them. And it can also help increased compliance and security. So making sure there are only legitimate transactions, there is no money laundering that is going on. All of them, you can get a real-time visibility into those transactions. So those are the key benefits of bringing this into blockchain. So I'm going to take one specific application. So this is actually a project that was initiated by the Monetary Authority of Singapore. This, by the way, I'm grateful to them for providing some of these slides. So the Monetary Authority of Singapore is the central bank in Singapore. So the currency there is the Singapore dollar, SGD. And this project, UBIN, is about bringing the Singapore dollar onto a blockchain platform, onto a distributed ledger. So what does it really mean? So they want to experiment with trying to bring the Singapore dollar as a virtual currency on blockchain. So this is over and above the physical currency that is actually transacting in Singapore today, that people might have as physical cash. They're trying to bring Singapore dollar as a virtual currency on a blockchain platform. It's an experimental phase, of course, but it's a very welcome step. And many other central governments are looking to do the same. And by the way, the Indian government, the RBI, has also issued statements saying it is exploring some of these applications as well. But Singapore is always at the forefront of innovation, so they're already trying this out. So the phase one of this project, UBIN, is just handling domestic payments within Singapore itself using the central bank issued SGD equivalent. So I said this is a virtual currency, is an equivalent of the SGD today, and they're testing it out. So the first phase of the project was implemented on Ethereum, which is another blockchain platform. These are some of the things that they tried to do. What are some of the functions that they tried to do is pledging collateral for depository receipts. I'm not going to go into the details of some of these financial terms, but think of it as just payments in some ways. And there are many instruments of payment, so some of those they tried to do it on blockchain. And it was trying to explore connectivity of existing banking systems with the blockchain. How does that work? What do the banks have to do to connect to the blockchain, to exchange payments on blockchain, right? And it also looks at connectivity of the current MAS electronic payment system. So they have something called MEPS, and they were trying to connect that system with blockchain. So that was the overall scope of phase one. And this is a high-level architecture of the phase one UBIN project itself. So I'm just going to I'm not going to go into too many details, but I think the key takeaway is that the blockchain is going to be only a part of the solution. Like I mentioned before, there are many other components that you have to integrate with. So you'll probably have to integrate with the bank's existing systems, their web interface for banking employees to be able to access this should be made available. So if they make a payment from their existing UI, it should then get connected to the backend bank systems and then connected to the blockchain network itself. And of course, MAS needs to connect to this to see what transactions are going on. So MAS has a portal for seeing what transactions are there. And of course, the payments themselves have to move around. So how those connectivities are made, all of those have to be figured out. So there are really many off-chain components beyond just the blockchain. So blockchain may be 20% of this entire architecture, but there are many other things that you need to be taking care of to bring the whole application alive and actually being able to do even something like payments. So phase 2 of the project, they're taking it a notch further. They actually now have 70 plus project members. There are 10 or 11 participating banks today, some big names in there. They're all trying this out on blockchain. And there is the Monetary Authority of Singapore, as well as the Association of Banks in Singapore, and the Singapore Stock Exchange. So all of them are part of this ecosystem now, testing the waters. And there are 5 technology partners: Accenture, Consensus, IBM, R3, and Microsoft. So these are the technology partners. And what they are doing is they are implementing this kind of a payment application on 3 different platforms. So they are implementing it on Corda, Hyperledger Fabric, and Quorum. So we looked at Hyperledger Fabric in detail. Later in the course, we'll look at probably Quorum and Corda as well. So these 3 platforms were evaluated for the payments application, and there were multiple banks that were participating in this. And there were many tools that were used, and there were many learnings from this exercise. So I think the phase 2 just got completed, and they're really looking to ramp up to future phases going forward. What were some of the learnings? I think one of the learnings was that there is actually a trade-off that you need to be aware of. Right? One is, on one side, resiliency. A centralized counterparty, let's say MAS previously was handling all the transactions, all the payment transactions, but then it made sure that if the resiliency was limited, only one node one organization was doing that. On that side, there is privacy, which is who can see which transactions. In the current world, when you are relying on one central counterparty, which is this end of the spectrum, what you get is privacy. No one else can see which transactions you perform, so you get privacy. And you also get liquidity. I'm not going to go into the details of this, but it allows you to maintain a low liquidity to be performing these transactions. So you don't need to have a high amount of currency in hand to be participating in this. So that's what is the case in the current centralized system. You get privacy and liquidity, but you don't get resiliency. If you're looking to do all participants with full visibility of all transactions, which is how it is in the Bitcoin world or in the Ethereum world, everyone can see all transactions that are going on. In that case, you get resiliency, you get liquidity, but you don't get privacy. Right? So that's the trade-off. But if you're doing, let's say, a permission network like Hyperledger Fabric or Corda, you can do gross settlements only. So you can get privacy of transactions because these platforms support privacy. You can get resiliency because it's still a decentralized system. Multiple nodes are executing these transactions. There is problems with liquidity. So that's what they realize. So there's actually a trade-off between what you can get. And they're trying to see if this trade-off can be resolved somehow, whether some of these platforms can give you a mix of everything, right? A good mix of all of these properties. So I'm going to go over this slide quickly, right? In phase 2, some of the things that they are looking to get is, of course, digitization of payments. You want decentralized processing. So you just don't want one node to be doing the clearing and settlement. You want all the nodes to be involved in that. And you want to do that in a decentralized fashion on blockchain. You want privacy of transactions. So only the participants of a transaction should be able to see what that transaction is about. You want settlement finality, which again is not there in the Bitcoin and Ethereum world. Because they use proof of work and there could be forks, it's actually possible. You might not know immediately if your transaction is final. It might take maybe even an hour for you to see whether your transaction is final. And there's also liquidity optimization, which is on the financial side. Okay, so that was Project Open. I hope you got a flavor of some of the real assessments that are going on for building some of these production grade networks, especially for payment. So hope you got a flavor of that. Now we're going to slowly transition towards some of the securities trading aspects for capital markets in some sense. Capital markets is probably the biggest in terms of monetary value, the biggest transformation one could think of that blockchain could come about. People are trying to test the waters with small use cases today. If you wanted to bring the entire stock exchange on blockchain, that is not feasible today, in my opinion, because the scale is just way too big. Blockchain is not mature enough to handle that. But if we can scale up to that, there are significant benefits to bring in some of these securities trading onto blockchain. So what are some of these things that are being done? One use case is on commercial paper, right? So what is commercial paper? So commercial paper is again a trading instrument. Organizations routinely come up with commercial paper. So this is a kind of an agreement that they say it's like an IOU. They sell this commercial paper in exchange for money, in exchange for some amount of investment. And one commercial paper can be bought by multiple people. So let's say I release a commercial paper worth $100,000. I could find 10 participants, 10 other organizations willing to pay $10,000 each to buy that commercial paper. So each of them buy a portion of the commercial paper, and together that commercial paper is then issued. Now, what happens is the commercial paper has a certain time period for which it's valid. At the end of the time period, the borrowing organization will repay all the initial investing organizations, right? So when they repay, they of course repay with a certain interest associated with that commercial paper. This is standard practice in the enterprise world today, and enterprises exchange these commercial papers on a routine basis. So today, this process is extremely manual. There are many intermediaries that are involved that make this system possible, and this top level picture shows the current state of how commercial paper works today. A potential future state, this is not a reality today, people are investigating this, there are some proof of concepts that have been developed. A potential future state is to bring some set of these entities onto a blockchain platform where they can get some of the benefits of automation. So you can get away from some of the paper exchanges that are being made today. You can get to automation, you can improve efficiency of these processes. You can improve transparency and immutability. So today there could be discrepancies as to, let's say, when the actual paper matures, how much interest needs to be paid, there might be discrepancies. And there's also high volume, right? So because of that, there could be discrepancies because people are manually noting down some of these details. And hopefully, because of these improvements, you can bring down the cost of issuing some of these papers, commercial papers. So that's one use case where blockchain is being actively investigated. So securities trading, like I mentioned, is again an important area where blockchain is being applied. So today IBM is working with both Japan Stock Exchange, London Stock Exchange, and many other entities to actually do some of the post-trading settlement. So what does that mean? So let's take this picture. This kind of describes some of the entities that are involved, how they are actually participating in securities trading. The stock exchange, so of course, let's first talk, there is a purchaser and there is a seller. Typically, both of them have a custodian that they work with. These might be service providers. These are organizations that manage the stock holdings of the seller and the purchaser. Now, the stock exchange is responsible for matching bids. So the seller will say, I am willing to buy a particular piece of stock at this price. The other way around. The purchaser says, I'm willing to buy this stock at this price. The seller will say, I'm willing to sell this stock at this price. And the stock exchange will match these bids. So that's what the stock exchange does. So there are brokers in between that get the sellers and buyers the best deals possible. There are market makers involved. And the clearing house. The clearing house is an important entity that is responsible for validating these transactions. So for instance, it will validate, I'm just going to make it up, they're going to validate whether the seller actually has the stock to sell. And likewise, does the purchaser have the money to buy, right? And the clearing house also does the function of netting. What the netting is, the seller, for instance, might be doing multiple transactions, each selling some amount of the stock. Or they might, within a day also, they might be selling and they might be buying again. So all of these are all compacted together. And at the end of the day, they will resolve and say, this is the net result. Saying A has purchased so much stock, B has sold so much stock. They've looked at all the transactions, combined them together to look at what the final balances should be. Right? So that is the job of the clearinghouse. There is also a settlement phase. So there is a settlement phase which is basically actually executes the final state. So it'll actually go and set the final state of all holdings to the correct numbers. There are security depositories that keep track of ownership of each stock, how much each who owns which stock and so on, right? So all that is being held. So if you think about this, a very complex ecosystem of participants, each performing a different function in this ecosystem, and there are a lot of inefficiencies today, and there are mistakes that happen that need to be manually resolved. And the hope is with blockchain, some of these processes can be automated, can be made more efficient, and reduce cost and time for settlement. So this is again just a life cycle. I'm not going to go into too much detail. So the clearing, like I mentioned, there are going to be multiple transactions that are submitted. These transactions are all batched together, maybe at the end of a day. It could be at other intervals as well, but let's say at the end of the day, they're all batched together. The clearinghouse will then determine what is the net settlement across all of these entities, who owns how much of which stock at that time. So now the clearinghouse is a centralized entity here. And then there is a settlement house, again a centralized entity today, which is going to execute these transactions in that across the batch, and say, okay, this is the final value for all of you, right, for every participant. And today it happens T+1. So T+1 is today. If the trade happens today, the clearing will happen the next day, and settlement might happen 3 days from now. Some countries follow a T+3 trade life cycle. Some of them follow T+2, some T+1. It depends based on country. But roughly the process followed in the stock exchange and post-trade settlement follows this life cycle. So we want to bring this process onto a blockchain network, where you can provide some of the same transaction properties along with privacy that's needed, and improve efficiency, automation, visibility into what is really happening, right? And because the volumes can be really big, people are trying to do this in some of the low liquidity markets, right? So these are some of the benefits that I mentioned: reduce the settlement time, reduce the risk of settlement. What if something does not happen, right? A transaction does not go through. There is a certain risk that you are incurring. So you're trying to reduce some of those risks. So people are trying out with low transaction volume markets. Rather than going to the entire trading volume, people are just testing waters, I would say, at this time. There's also the area of private equity. So there are certain companies that are not publicly listed in the stock exchange, but they do provide a notion of equity and ownership, and different people, organizations may be owning different amounts of equity with a private company. And today there is a whole ecosystem and infrastructure that supports private equity handling. And very little innovation has come into this whole private equity space in a very long time, right? There's very little innovation that has happened. And there's very little transparency also. So really people don't know who really owns portions of this company, and there are lawsuits that happen because people claim different amounts of ownership and so on, right? So what blockchain can bring in is, if you actually bring in all the owners of, so these owners of private equity are typically high net worth individuals. It could be institutional investors, could be large banks that are investing in companies, right? So bringing all of them onto a blockchain network can significantly improve insight into transparency. It can provide transparency. It can also support compliance and regulations that local countries might have on private companies. It can help bring in the required amount of regulatory access, right? Today, there are a lot of compliance issues. Although governments do have compliance norms provided for private equity, there are a lot of issues that happen, a lot of lawsuits. So we can bring in that regulatory oversight almost in a real-time manner, and there are a lot of benefits for that. And today, IBM is working with Northern Trust, and this private equity administration is actually running in production on Hyperledger Fabric today. Okay, so that brings us to the end of this lecture, where we've looked at just two applications, right? Almost at a broad level: payments and securities trading in financial services. We're going to look at other applications in financial services over the next two lectures. But I think there's a lot of fun reading that you can look into. There's a lot of financial services concepts, For instance, if you are not aware of the real-time gross settlement system that's in vogue today, RTGS, you should check out the Wikipedia article that describes this. A lot of countries adopt this today. You can look up Project Ubin, and there are a lot of reports that are available. So the code for Project Ubin is also made publicly available. It's in GitHub. So you can go look up the code as well. GitHub link is here. So if you are not aware of commercial paper, then you can look up the Wikipedia article of what commercial paper really is in today's world. There is a small demo on Hyperledger Fabric of building a commercial paper application. There's a YouTube video of that. And again, private equity and what it means, some of the issues with it. Again, a Wikipedia article for that. So I would encourage you to explore this space if you're really interested in the financial services space and how people think it's going to completely transform the financial services industry today. With that, thank you and see you soon.